We're going to find the 20th term of this series where a is 360 and r is 7/8. So if we want the 20th term, we're going to use the formula where un equals ar to n minus 1. So a equals 360 times by r, 7/8, to the power of 20 minus 1, which is 19. And you put that in your calculator and you should get 28.5 to 3 significant figures. Now we're going to find the sum of the first 20 terms of the series. So Sn, sum of the first n term, is equal to a times 1 minus r to the n all over 1 minus r. And that equals to 360 times 1 minus 7/8 to the 20 all over 1 minus 7/8. And you just put that into your calculator and you should get 2,680. Now in the final part of the question we've got to find the sum to infinity, and the sum to infinity is equal to a over 1 minus r, provided that r is between minus 1 and 1, which we do have in this case. So therefore the sum to infinity will equal a, which is 360, over 1 minus 7/8, which equals 360 over 1/8, which is the same as 360 times 8. And that comes out to be 2,880. A circle has centre 1, minus 1 even, 7, and passes through the point 0, 0. We want to find the equation for C. We've got a general format for the equation of a circle that we know, and that is x minus a squared plus y minus b squared equals r squared, where the centre of the circle is AB. So we know that A is going to be plus, we're going to have plus 1 here for the x, and for the 7 we're going to have minus 7 here for the B. So we're going to find R. And the way we find R is we will need to find the radius of the circle. And the easiest way to do that is we should take the centre minus 1, 7. And we know that it goes through the point 0, 0, which will be about here somewhere. So we need to find the radius by using Pythagoras. So we know that distance there will be 1, and this distance here of our triangle will be 7. So r squared will equal 1 squared plus 7 squared, which equals 50. So the equation of our circle is going to be x plus 1 all squared plus y minus 7 all squared, and r squared is just 50, so we can just write in 50. In question 3, we need to find the first 4 terms of the binomial expansion in ascending powers of x of 1 plus x to the 4, given each term in its simplest form. Now the trick to the binomial theorem is quite simple to remember if you just follow some simple rules. If you were to just have a plus b to the n, then the formula for the binomial theorem starts off with nc0. Hopefully you're familiar with this notation. If you're not, do look up this notation, what it means. And n0 in this case is the same as nc0. We have ncr as the formula, where r is the rth term. Anyway, the first term is always 0 in a binomial. It doesn't start at 1, it starts at the 0th term. And we have a to the n, we have b to the 0, plus n1 a to the n minus 1, take off 1 power, b to the 1, plus n2 a to the n minus 2, b to the 2, and so on. You just keep going along. You keep decreasing the power of a by 1 and increasing the power of b by 2. And in the NCR formula you just change the bottom bit up by 1 to correspond with the power of b. So let's put that into action. Now here we've got to realise that all of x over 4 equals b, and a common mistake is not to raise all of that to the right power when doing it. So we can find the first 4 terms. So we're going to do 8 0 of 1 to the 8, and obviously x over 4 to 0 will be 1, plus 8 1 of 1 to the whatever is going to be 1, times by x to the 4 to the 1, sorry, x over 4 to the 1, plus next term will be 8c2 times by 1 to the 6, which is just 1, and times by x over 4 to the power of 2. Notice all of that's to the power of 2. Common mistakes, just put the x and forget about the 4. Always do all of it to the power of 3. And the next term, again, notice we're going 0, 1, 2, 3, just going up by 1 each time. We don't need to worry about the 1 because 1 to the power of anything is 1. So let's just bring the power of the x to the 4 up again. It was squared last time, and now we're going to go cubed. Let's simplify that. This just comes out to be 1. Plug these into your calculator. This just comes out to be 8 times x over 4, which just gives you 2x. The next term, once you've calculated 8c2 times by 1/16, you will simplify to get 7 over 4 x squared. 8c3 times by a quarter cubed. When you simplify that all down, you get 7/8 x to the power of 3. And this gives us our first 4 terms. Okay, we're now going to use our expansion here to estimate the value of 1.025 to the 8. So what you've got to realise is what's in the brackets must match up what's in the brackets here when doing your estimation. So you get 1 plus x over 4 must equal 1.025. That implies that x over 4, if we take away 1 from both sides, is 0.025. So times this by 4, and we get x is equal to 0.1. Put that into this expression. So therefore we're going to have 1.025 to the 8 is approximately equal to 1 plus 2 times 0.1 plus 7 over 4 times 0.1 squared plus 7 over 8 times 0.1 cubed. Now it's important you calculate these terms out. So we get 1 plus 0.2 plus 0.0175 plus 0.00875, and that equals 1.2184. And the key thing to this question, most of you will get it right so long as you get your calculation of x right. And remember, it's by making this bit here, okay, this bit here, equal to what's inside the brackets and finding out your value of x as a consequence. Question 4. Given that y equals 3x squared, show that log 3 of y equals 1 plus 2 log 3 of x. That's the first bit we're going to do. So y equals 3x squared. Well, let's take log to base 3 of both sides. So log to base 3 of y, because we've got log 3 of y, so it just makes sense that we make these two things match up. So let's just take log base 3 of both sides. And if we do that, we get log base 3 of 3x squared. Now this is a case of where you need to know your logarithm laws. Now you've got two things times together, 3 times x squared. You can split them up using the addition rule. So log 3 of 3 plus log 3 of x squared, this was equal to this. Log 3 of 3, what power does the raise 3 do to get 3? Well, that is just 1. And then there's the power law where we can bring down the 2 outside the logarithm. And this shows the result that we want. Let's look at this question now. And it says hence or otherwise. Well, hence is always a good idea. And we can see that this bit here matches up with this piece here. And we just proved that I equals that. So why not replace that with this? We know that 1 plus 2 log 3 of x is equal to log 3 of y. For part B, replace that with log 3 of y. and that equals log 3 of 28x minus 9. Now we can raise both sides to the power of 3 to undo the log 3. So that implies that y will equal 28x minus 9. Let's go back to what y was equal to. Y was equal to 3x squared. So therefore we can replace this y with 3x squared. So this implies that 3x squared equals 28x minus 9. And we find we've got a quadratic. Subtract 28x from both sides, add 9, and we get that equals 0. Now, does this factorise? Yes, it does. 3x, open brackets, x. Well, the 9 times 3 if we're going to get anywhere near the 28. And we've got minus 9 times 3 gives us minus 27. Another minus 1 times 8 gives us the 28x we need. So therefore, x must equal 1/3, this must equal 0, or x must equal 9. F of x is divided by x plus 2, and the remainder is 7, and we're going to show this. So we're going to use the remainder theorem. The remainder theorem, what we do is we make this bit equal to 0, so x equals minus 2, gives you that 0. When we put minus 2 into this, that will give you the remainder is 7. That's the remainder theorem. So let's find f of minus 2. And that is equal to minus 2 cubed plus a times minus 2 squared plus b times minus 2 plus 3, and that is equal to minus 8 plus 4a plus minus even 2b plus 3, and we know f of minus 2 is 7. Let's simplify that. So we get minus 8 plus 3 is minus 5. Add that on 7 gives us 12 equals 4a minus 2b. So therefore 6 will equal 2a minus b. Now when this is divided by x minus 1, the remainder is 4. So f of 1 equals 1 plus a plus b plus 3. What I've done here is I've put 1 into wherever x is here. Okay, so you get 1 plus a plus b plus 3 when you do that. Now we know that that is equal to 4. Let's simplify this. So I get 4 plus a plus b. So I get 0 equals a plus b. So a equals minus b effectively. We call this equation 1 and this equation 2, and we substitute 2 into 1, solve the simultaneous equation. So wherever there is a minus b, we can put an a. So you get 6 minus 2 equals 2a plus a, because minus b equals a. We can just replace it with a. So therefore 6 will equal 3a. Therefore 2 is equal to a. Divide both sides by 3. A equals minus b, so therefore b will equal minus 2. Right, in question 6 we have a table of values here which corresponds to this graph and gives the x and y values for this equation. Now what we need to do first of all, part A, is to find out the values of y corresponding to 2 and 2.5. So first of all we're going to put 2 into this function, and when you do that we get the answer of 4. 16 divided by 2 squared is 4, divided by 4, 16 divided by 4 is 4, and we've got 2 divided by 2 is minus 1 plus 1 will give you 0, so that will just give you 4. Now this one we'll plug into our calculator and we get the answer 2.31 to 2 decimal places or 3 significant figures. Now we're going to use the Trapezium Rule of all the values in the table to find approximate area for R. Now you need to be careful with this when doing Trapezium Rule type questions. This is quite easy because you can see the gap. The gap is always 0.5, so we know that h in our formula equals 0.5, the height of our trapezium. Often you're asked to do it with 5 ordinates or 4 bars or what have you. If you're asked to do it with 5 ordinates, which are these values, then realise you're only going to get one less bar. So when calculating the width of the bar, you need to divide by one less number. Notice here we have 1, 2, 3, 4, 5, 6, 7 ordinates, which actually gives you 6 bars. And when you've got a distance of 3 to be covered, 3 divided by 6 gives you 0.5. A common mistake is actually to do 3 divided by 7 when you're not given all the values and you've got to work them out for yourself. So just be warned. So anyway, the area is approximately equal to a half times by h, which is 0.5, times by the first and last values added together, so 16.5 plus 0, plus 2 times all the other values. All the other values, because you're adding up a series of trapeziums. Remember, in the Trapezium Rule, you divide this up into trapeziums. And you add all those areas, and in those areas you end up doing that plus that as a calculation, and then times it by the height and dividing by 2. Now you do that for every single trapezium, so the middle bars will get counted twice, and the end bars only get counted once. It's a nice way to help you remember the fact it's just the middle bars that are added twice. So add all those. I'm not going to have space in there, let's just put the values down here. Plus what we got, 1.278, 0.556. And when you calculate all of that, you get 11.88 to 4 significant figures. Now, well, 2 decimal places is what we're working with, is 2 decimal places here. Now, one thing to remember is it's important you write all the numbers out in the substitution. That's where you get your method marks from. Don't just write h is 0.5, the answer is that. Make sure you do write down all your working. Now, the next part of the question, we're going to use integration to find the exact value of r. So we're going to integrate between 1 and 4, 16 over x squared minus x over 2 plus 1 dx. Now the best thing to do is to simplify this as a power of x. So we've got between 1 and 4, 16 times x to the minus 2 minus a half x plus 1 dx. And that is equal to, put your limits in, integrate this, add 1 to the power, we get x minus 1, divide by the power, so 16 divided by minus 1 will give us minus 16. Add 1 to the power, so we get x squared. Divide that by that power, so we're going to get minus a quarter x squared. 1, add 1 to the power on that, will give us x to the 1. Divide by 1 gives us just 2x. So let's put 4 and 1 into this. So 4 into here will mean minus 16 divided by 4, which will give us minus 4. 4 squared 16 divided by 4 gives another minus 4, plus 4. Minus open brackets minus 16, put 1 into there, get minus 16, put 1 into there is minus a quarter, plus 1. And this cancels out with this, so it gives us minus 4, and in here we've got minus 15 and a quarter. So we get minus 4, minus a minus gives us a plus 15 and a quarter. So that gives us 11 and 1 quarter. Notice that this answer was bigger. You can see why it would be bigger, because if you turn this into trapeziums, we zoom into this, you can see that the line is just above the curve, and hence why this area will come out bigger than this area, which is the area under the curve. Right, we've got a sector here and with a triangle drawn inside it. We know that the angle here is 0.95 and we're told that the radius is 6, and we want to find the length of the arc BC. So the length of the arc is equal to r times theta, which in this case is equal to 6 times 0.95, and that gives us a final answer of 5.7 centimeters. So we want to find the area of sector ABC. Now the area is equal to half r squared theta. So that will equal a half times r squared, which is 36, times 0.95. And when we work that all out, we get 17.1 centimeters squared to 3 significant figures. Now, what we're going to do next is we're going to try and show that the length of AD here is 5.16 centimeters. We're told that BD is drawn such that BD is equal to AD. So we have an isosceles triangle. And there's several ways to do this. We know the length of this side, and we know the angle here. And if we know the angle here and we've got isosceles, we know that this angle is also 0.95, and hence we could find this angle here as well by taking that away from pi by 2. So this angle here, let's call this, we're going to call it, we've got AB, so let's make this one C for the sine rule purposes. So we know that C will equal pi by 2, not pi by 2, pi, because there's pi in 180 degrees inside a triangle, minus 2 times 0.95. And this comes out to be 1.24. So if we use the sine rule, we can see that we've got b over this side, which is we're going to call little b. We've got c over sine c over little c equals sine b over little b. Although we want to find sine, so let's do it. Little b over sine b equals little c over sine c. So we know that little b over sine b, using the sine rule, equals little c over sine c. Always label the triangle the way you want to. Ignore the labels given in the question. So use the labels you want to make the formula easier. So I've got b over sine b, so I've got b over 0.95 equals c, which is 6, over sine of 1.24, which I've already worked out. And we rearrange that so to get b is equal to 5.16. 6 divided by sine 1.24 times by the sine, sorry I left out the sine there, of 0.95 will give us 5.16. Therefore AD equals 5.16 to 3SF. Now the next part of the question, we want to find the perimeter of R. We want to find the length of all these sides. So we're going to use AD, which is 5.16, to help us do that. AD is this length here, which must also be this length here. So this side is 5.16. And this side is going to be 6 minus 5.16. And we know this length of this side because we found it in part A as 5.7. So here we have 5.16 here for this side. This side along here we have the answer that we previously found, which was 5.7, and in here we've got 6 minus 5.16. So the whole perimeter is equal to 5.7 plus 5.16 plus 6 minus 5.16, and that adds up to equal 11.7 to 3 significant figures. Remember to use all the accurate values of these, not the rounded values which I have shown in this question. You should always keep all the accurate values in all the questions all the way through, and make sure you only round at the very end of each answer. You can write down approximations like I've done, but only the final answer should the calculation you're using be rounded and given. Now we want to find the area of R to 2 significant figures. So what are we going to do to find the area of R? Let's go back to this diagram again. Well, we've got the area of the sector, and we can take away the area of this triangle. So we can use a half r squared theta, which we've already done in the first part of the question. We've got the area here to be 17.1, and we're going to take away that the area of the triangle. Now the area of the triangle is equal to half AB sine C, or in our diagram we're going to change the A for the C, so it's a half CB sine A. is the way we're going to look at it. So half times CB, so where are we? We've got C times B, so we've got 6 times 5.16 times the sine of A, which is 0.95. Actually, I could have easily done half AB sine C, because I've got B and I've got A and I've got C, so I could have done it that way as well. And when we calculate that, we get an answer of 12.6. So therefore the shaded area is equal to 17.1 minus 12.6. 17.1 being the area that we found for the sector earlier. And that gives us an answer equal to 4.5. Okay, here we have a flower bed, and we are going to show that y equals 16 minus pi x squared over 8x. Well, we know that the area is equal to 4 meters squared. We know this length is y and this length is x. And we know this is a quarter circle with radius x, so that distance is going to be x. This distance is going to be x. This distance is going to be y. And this distance is going to be x. So, let's write down what the area of all of this is going to be and see where it takes us. So we know that the area is going to equal x times y plus, this is obviously going to be x as well, and this is y, x times another x times y plus this area here. Now if this is x and this is x, it's a quarter circle. So we know it's going to be, theta is going to be 90, well it's a quarter circle. Let's just take the area of a circle as pi r squared, so pi x squared, and divide it by 4. So therefore the area equals 2xy plus pi x squared over 4. Now I want to rearrange this to make y the subject. So therefore we can see from this, we take this away from both sides, we're going to get a minus pi x squared over 4 equals 2xy. Let's write this as a single fraction. And we get 4a minus pi x squared over 4 equals 2xy. Now we know that a is equal to 4, so this is going to be 4 times 4, which is 16. So it's equal to 16 as a equals 4. Now we're going to divide both sides by 2xy, so we're going to get on the bottom 8x equals y. So we're dividing by 2x to get 8x on the bottom. And we've shown that this is true. Okay, next we want to show that the perimeter, p meters of the flower, is given by the equation p equals 8 over x plus 2x. I'm just going to include what we had up there. So in our diagram we know that this is y, we know this is x, this is y, this is y. Let's just rub that out so we can see what's there. This is y, x, y, and we've got to work out this length, which is obviously going to be a quarter of the radius of a circle. So it's a quarter of the circumference of a circle, and the circumference of a circle is 2 pi r, r being x, so we're going to get 2 pi x round here. So the perimeter will equal 2 pi x plus 1, 2, 3, 4y plus another 2x. But we know that y is equal to all of this. So we're going to replace the y with all of that. So we get 2 pi x plus 4 times, when we do 4 times all of this, we can just divide the bottom by 4 to get 4 times all of this. So that will just leave us 2x on the bottom to simplify. That would be a much easier way of doing it. So we get 16 minus pi x on the top, x squared, and we're going to make that 2x on the bottom because we're timesing by 4. And we're going to add on another 2x here. So let's just simplify this all out. So we get 16 divided by 2x here, which is 8 over x, minus pi x squared over x. Well, the x is going to cancel to give you that. So that will be minus pi x over 2. And made a cock up. Alright, we're going to show the perimeter equals p meters. Right, we're going to show that the perimeter is given by this equation. Let's go back to our diagram. And we can see this length here will be y, this length will be y, this length will be y, this length will be x. This is a quarter of a circle here, so therefore it's a quarter of the circumference. The circumference is given by 2 pi x. What we need to do is divide that by 4. So therefore we get the perimeter to equal 2 pi x over 4 is just pi x over 2 plus 1, 2, 3, 4 lots of y plus 2x. Already we can see we've got the x, the 2x that we want. Now what we're going to do is we're going to replace this y here with the y we had in there to make sure it's all in terms of x. So we get pi x over 2 equals 4 open brackets 16 minus pi x squared all over 8x plus 2x. And this equals, that's not going to change much, nothing to simplify there at this stage. So we've got 4 times all of this, so 4 times 16 equals 64 minus 4 pi x squared all over 8x plus 2x. And we get pi x over 2 plus 64 divided by 8 is just 8 over x, and minus 4 pi x squared. What we're going to do here is we're just going to cancel out the 8 there with that x squared, the x there with the x squared there, so it leaves you just pi x. 4 over 8 will cancel down to just leave you 2 on the bottom, so we get minus pi x over 2 plus 2x. And we can see straight away that we can cancel this out with this, which equals 8 over x plus 2x, what we wanted to show. Now we want to use calculus to find the minimum value of p, so we're going to find dp by dx first. dp by dx, well, let's rewrite this as 8x to the minus 1 plus 2x. Then we can take times by the power and take 1 off the power. So times by minus 1 gives us minus 8. Take 1 off the power gives us x to the minus 2. And do the same here. This just goes to plus 2. Now to find the minimum value, we need to let dp by dx equal 0. And this is the same as 8 over x squared. Or minus 8 over x squared. Don't lose your minus signs. So we times that by x squared, we will get 0 equals minus 8 plus 2x squared. Some of you might prefer to actually have the 2 on the other side. So if I just do a side note, yeah, we've got, as a side note, we've got 0 equals 8 minus 8 over x squared plus 2x. Take the minus, we've got minus 2, plus 2 even, no x there. Take the 2 to the other side, you get minus 2 equals minus 8 over x squared. And then you're going to times by x squared to get minus 2x squared equals minus 8, which gives you x squared equals 4. Now let's just carry on with the way that I was doing it. I get 8 on this side, adding 8 to both sides, 2x squared, so I get 4 equals x squared, in exactly the same answer as I did with the other method. Square root both sides, I'm going to get x equal to plus or minus 2, therefore x must equal 2. We can't have a negative length. So if x equals 2, then p will equal 8 over 2 plus 2 times 2, which gives you 4 plus 4, which is 8. Now it just says find the minimum value p. It doesn't say we have to show as a minimum. Now we're going to find the width of each rectangle when the perimeter is a minimum. Give your answer to the nearest centimetre. Now previously we found that y equals 16 minus x squared pi x squared over 8x. So let's just put that value of x, which is 2, into this equation to find the width of each rectangle. So y will equal 16 minus 4 pi all over 16. So therefore the width is 1 minus pi by 4. We want to give our answer the nearest centimetre. And what we need to notice is that this comes out as 0.21460, and this is in metres. So therefore the nearest centimetre it will be 21 centimetres. To the nearest centimetre. Okay, we're going to find the solutions to this equation here. So let's start off with the equation itself. So sine, open brackets 3x minus 15 equals a half. And we do inverse sine, undo the sine of both sides, and use sine of minus 1 button. That will give us 30. Now that's not going to be the only answer that gives us. So what we need to do, we need to check our range. Notice here's the range that's given. Now we've got a transformation here. It's been transformed, it's not just sine x, but we're looking at sine of x, 3x minus 15. Now it's important you look for your range at this stage here, because it's very difficult to find the other angles at any other stage. This is the only stage you can do it. So check your range here. So rearrange this equation. If we add 15 to that side and divide by 3, we get 5. And then if we add 15 to that side, so we get 180 plus 15 is 195, and times that one by 3, we get 585. So x must be between these values. So we're going to look for all the other values in this range. Well, I like to use the unit circle method, where we know that we have all stations to Crowthorne, or any city you like beginning in C, and that's where we come from. And we know that the angle we've got already is 30 degrees. Now we're dealing with sine, so we look across to where, and it's positive, everything's positive in this region, so we look to where sine is also positive to get other answers in the circle. Okay, when you do the unit circle, as you move round, whatever the projection is onto the y-axis is your value of sine. So notice sine is always positive when you're in this half and negative in this half. Now cos is your projection onto the horizontal axis. So notice cos will be positive up to here, then it's moved to the negative axis, still negative axis, and it goes positive again. And it's this length, the projection on here, if you were to project down. Now tan is sine divided by cos, so we can work that out by just comparing sines. Anyway, so we know that this is going to be 30 degrees, so we have an angle here of 150, because you always start off at 0, go to 90, go to 180, 270, and so on. Now we're going to keep going around looking for more values that is in this range. So we add on another 360 to 30 to go all the way around. That gives you 390. Add on 360 to 150. Well, 50 on to 360 is 410, so that will get you to 510. Now if we go around to here, we can see we can add on over 180, which is going to take us past the 585, so we don't need to get any more answers. So our complete set of answers for 3x minus 15 is going to be 30, 150. Now we need to add on to that 390 and 510. Now some of you might not like this method. Well, you've got another method you can do. You can draw a sketch of the sine curve. The only problem is you have to keep going on and drawing more curves. And here is where the sine equals 0.5. First time is at 30. The second time is at 150. The third time is at 390. And the fourth time is at 510. So you can see how you can look up the extra values using your graph. Now we're going to add 15 to all of these and divide by 3. So 30 add 15 is 45, divide by 3 is 15. 150 add 15, that gives you 165 divided by 3, which gives you 55. Add 15 to 390, you get 405 to divide by 3, which is 135. And if you do 5, 10, and 15, you get 525, and if you divide that by 3, you get 175. So I'm going to put that in here. So these are our final answers to the question. Right, we're going to look at the next bit. And here we're going to look at these points on this graph. This graph is a transformation of the sine curve. It's been transformed to sine ax minus b. And the simplest way to find a and b is actually just substitute these values in, but you're going to be quite careful with your calculations as you move on through the question. So let's put 10 naught, pi by 10 naught in. So you're going to get naught equals sine of pi by 10 times a, so a pi over 10, minus b. In the next one, we're going to get naught equals sine of 3 pi by 5 times by a minus b. We've only got two unknowns, so we only need two equations. So there's no really need to look at the third one, but we will look at the third one in due course. Now if you do inverse sine, now the inverse sine, the first value you're going to get, your lowest value when you do inverse sine, is obviously going to be naught to get naught. So this function here, let's just call this a and call this b. So a will imply that we have naught equals to a times pi by 10 minus b. Now b will be the next time the sine curve equals naught. Now we know that a normal sine curve looks like this, and it goes through naught and it goes through pi. So therefore the next time it equals naught is pi, and we've got 3a pi over 5 minus b here. Now we can simplify these two equations by just taking one away from the other. So let's just take the lower one away from the top one. So you've got a over, that's meant to be an a, it looks a bit like a 9 now, so let's just make that look more like an a. So we're going to take a over 10 away from 6a over 10, that gives us a half pi. So we're going to get naught away from pi is pi equals a half pi times a. So cancel out the pi's and we can see that a equals 2. Once we've done that, we can put that back into here and we can see that naught is equal to 2 pi over 10 minus b, and therefore b is equal to pi by 5.